All right, welcome back, everybody. And we are still in Chapter 7, Section 2. In our last video, we talked about how to solve exponential equations. And our first problem here that we're going to go through in this video is not solving an equation, but taking some information that we have about an exponential function that will allow us to come up with what the function is, given that information. It's kind of similar to problems in the past, where you would have something like, something like this. And normally I don't like writing things like this during a video. I would have written it ahead of time, but I just thought of it. It's like this. Write a linear equation with a slope of 2 that passes through the point 1, 6. So to solve that, you first need to know what the equation of a line looks like. So we know that that's y equals mx plus b. It tells you the slope is 2. That's m. And you know it goes through 1, 6. So x is 1, y is 6. You can use this to find b. So 2 plus b equals 6. b equals 4. Okay. So now that you know what all the letters are equal to, well, at least m and b, those are the only ones you really need. M is 2, b is 4. So that's the equation of the line. Okay, we wrote the equation of a linear. We wrote the form of a linear equation, and then we used the information we had to plug in the values for different letters until we knew what they all were. That's essentially what we're doing here. The main difference is the function is exponential this time. It's not going to be y equals mx plus b. It's going to be the form of an exponential function. So, the form of an exponential function is going to be, well, it's not y equals mx plus b, that's for the line. It's y equals, remember what makes a function exponential is that that exponent is a variable. So the x is up in the exponent, but the general form is this. Y equals a times b to the x power. And we saw in prior videos how this could be more complicated. We could shift it, we can change the shape, but in general, it looks like this. And I'm going to go ahead and erase my linear equation here. We don't need that anymore. So, in order to get started here, I want you to think about if x is 0, if this is a 0, what happens? If x is a 0, what happens? Well, anything to the 0 power is 1, right? So b to the 0 power would just be 1. So this would be a times 1. So y equals a. So if x is 0, oops, then y equals a. What this tells us is, if we've got a point that's 0 comma something, that's got to be the y-intercept. So a is the y-intercept. So how does that help us? Well, if one piece of information we have is where the y-intercept is, then that'll give us a. Do we know what the y-intercept is? Huh. It's 0, 8. Okay? If x is 0, then that means we're on that y-axis. This function crosses the y-axis at 8. So that means 8 is the y-intercept here. So we can actually plug in 8 for A. So we'll start there. Okay. So from this point, I kind of actually wish I kept my linear equation up here. If you want to rewind the video back to when this was here, take a look at it and think about what happened once we knew one of the letters. Like once we filled in the slope, what happened next? We plugged in the value of a point for x and y. That way we can find the letter that's left over. So is there a number we could plug in for x and y that we haven't used already? Because we've kind of used this. We can plug in this value. Well, this set of values. X would be 4 and y would be 2048. That should work. So I'm going to change this y to 2048. So we are just plug in x, y, coordinates from other point. Okay, so this is like what we're doing. And this is what it gets us. We're plugging in the x and y coordinates here, and for x and y here. The y is the 2048, and that equals 8 times b, x is 4. Okay, so this is what we have. The reason we're doing all this is so we can solve for b. Once we know what b is, we can write our function. So we're solving for b. We need to get this b by itself. First thing we should probably do is divide both sides by this 8. So we have, okay, now that it's just b to the 4th power, I can get rid of the parentheses there. They're not really doing anything. 2048 divided by 8. Just a second. 256. 256, how about that? Yes, I would need a calculator for that. I wouldn't recommend trying to do that in your head or on paper. Calculators are great. Use one. So we have 256 equals b to the 4th power. B isn't by itself yet, though. If we've got b to the 4th power and we just need b, there's something we need to do to both sides. Well, it's kind of like if we've got x squared equals 9 and we want to find what x is, how do we get the x by itself? We take the square root of both sides, right? This means x equals plus or minus 3. Okay. So the reason we take the square root is because the root is 2. The square root and the exponent cancel each other out. So if we've got b to the 4th, and we want that to be just b, then we need to, we're going to take the root of both sides, but what needs to be the number on the root to cancel out this 4th power? Just like these canceled out. It needs to be the 4th root. So I've got little 4s here. We're going to take the 4th root of both sides. Okay. So that's going to give us just b over here. We do need to find the 4th root of 256, though. We do need to find the 4th root of 256. No other real way around it unless you've got a calculator that can do this all at once, which maybe you have access to one. But if not, you're going to have to break that down. 256. I've got a calculator. 256. That makes me think of something in particular, and I'm wondering if it's 16 times 16. Yep. 16 times 16, 256. Now, we could break this down a whole lot further, right? We can break 16 down a lot of different ways. Think about what it is you're looking for when you're breaking this down. This root is a 4, so once we have 4 of something, we're going to circle them all, and if that's all we have, we're going to stop there. So 2 numbers multiplied to 16, there are lots of different ways you can do it, but probably the easiest is 4 and 4. And the reason 4 and 4 is easiest, how many 4s do we have? How many do we need? Hey, let's circle those 4s and say, oh look, B is 4. Okay, because there's nothing left over here inside the root. Now, when we did this, we said it was plus or minus 3. But here I'm saying B is 4. It's not plus or minus 4, and the reason for that is B is the number that's being raised to the x power here. This needs to be positive. Okay, that's the only way this is going to work. So this has to be a positive 4. So B is 4. We already know that A is 8. Okay, we did that here because A was the y-intercept. So if we know A and we know B, we're just going to write the exponential function with the A and the B filled in. Okay, the x and the y are going to stay x and y. We're just going to fill in both of these numbers. So we've got y equals A is 8. B is 4. And this is to the x power. Perfect. So this is the exponential function. And the graph of this, if you were to graph it on like Desmos or something else, you'd see that it goes through 0, 8, and it goes through 4, 2048. Okay. There will be a problem on the homework assignment for this section that is similar to this. And if you do not have something like this problem written out in your notes, this can be very, very difficult or impossible to figure out on your own. So if you're not taking notes, pause the video now, get this into your notes. If you've got your steps written out here, which I recommend, okay, that tells you what's going on here. I think that you can follow these general steps no matter what these points are. Although I'll give you a hint. One of them is always going to be the y-intercept, so you will be able to start the same way you started this one. Okay? All right. There are I haven't quite finalized the homework yet, but I think there are going to be 2 problems on the homework like this. And they both give you the y-intercept to start with. So you should be able to follow these steps here. As always, if you're working through the homework and you've got questions, let me know. Okay, so our next problem. We need to solve this. Okay, so we're going back to something more like what we saw in the last video. Okay, there is one, well, there are 2 main differences, I suppose. This is a fraction now. We didn't deal with fractions in any of the prior problems. We're going to talk about how to deal with that in just a sec. The other main difference is this. In the last video, we talked about how to solve equations. But now we see this is an inequality. And that doesn't really change things a whole lot. Doesn't really change things a whole lot. And you'll see what I mean by that. Because our first step here is the same as it was for those problems in the last video. It's to get the bases to be the same. Okay, we need to get the bases to be the same. And our bases in this problem, 5. And this fraction is considered a base. It's being raised to the exponent of 1 out here, but we don't see the 1. Okay, so we want this 5 and this 1 over 625 somehow to become the same base. Now, I don't know about you, but I don't really want to write 5 in terms of this fraction. I think we need to change the fraction so it becomes 5 to some power. Okay, so we need to write 1 over 625 as 5 to some power. Now, this 1, there's not much we can do with that. But the 625, I think we can write this number as 5 to some power. How many times do you have to multiply 5 by itself to get 625? Well, if you're not sure, hey, calculator. I'm just going to keep multiplying 5 and see how many times I have to do it to get 625. So 5 times 5, 25. Times 5 again, 125. Times 5 again, 625. So I had to do 5 to the 4th power to get this number. So this is 1 over 5 to the 4th. Okay. Now, we want to be able to write 1 over 625 as 5 to some power. This is not it yet. We can write this as 5 to some power. Do you remember how? If 5 to the 4th power is on the bottom of the fraction, and we want to bring it up to the top, this exponent needs to become negative. So this is 5 to the negative 4th power. Right? So, I'm going to rewrite the inequality that we started with here. This is 5 to the 3 minus 2x power is greater than, and now we know 1 over 625 is the same thing as 5 to the negative 4th power. Okay. Same first step as before. If you've got a fraction that you're trying to turn into a whole number base, that exponent is going to be negative no matter what, because you're going to have to take something from the bottom and bring it up top. Okay. So this is what we have now. And once our bases are the same, and our exponents are as simplified as they're going to get, there's nothing else we can do there. It's not like we have to distribute something anywhere in the exponents. This is where step 2. I'll be a little more formal in this video, as much as I want to say yeet, oops. That's not very professional. I'll say eliminate. We will eliminate the bases now. Now that they are the same, they don't mean anything anymore. They're not going to help us find out what x is. We have to get rid of them in order to find out what x is equal to, or to find out what x can be to make this true. So we get rid of the bases, we keep everything else. This is 3 minus 2x is greater than negative 4. 3 minus 2x is greater than negative 4. We just solved this inequality for x, just like we would any other time. Okay? So we want this x by itself. I would say move the 3 first. Subtract. This is negative 2x is greater than negative 4 minus 3 more. You're going further into the negatives. That's minus 7. And then to get the x by itself, right now it's being multiplied by negative 2. So we divide both sides by negative 2. And we get x. These negatives are going to cancel out. This is going to be positive 7 over 2. What sign goes there? If you say greater than, well, I wish, okay, so I put a special paint on my wall that allows me to write on it. Okay, I'm not writing on my wall. there is a clear whiteboard coating on it, but it only takes, well, it's a black marker. If that weren't the case, I tried writing on a different color, like over in the corner here, and it's kind of still there. So I'm only using black. But if I had the ability to write with different color markers, I would use my red one here. And I would circle these -2's. The thing that you have to keep in mind if you're dealing with inequality symbols like this one is if you're ever going to divide by a negative number, that sign flips around. Okay? I know you've done this before, but it's probably been a while, so it's okay if you forgot. But this is going to change to a less than sign. And it's only if you divide or multiply, but I usually find myself dividing by a negative number here. Negative number, flip the sign. So we get x is less than 7/2. Okay, so all values of x less than 7/2 make our original inequality here true. And in order to solve that, we did the same 2 steps as before. Getting the bases the same if you've got a fraction involves going through a process like this. Once you've got the bases the same, eliminate them. Write the exponents without the bases. Solve for x. So really step 3 is solve for x. Or whatever variable it is. It doesn't have to be x. This could be like a v or an f or whatever. Okay, solve for x. I'll say x though. Okay, so there were some new things in there. We dealt with a fraction here, turning it into the same base, and we have an inequality, but we found that it really doesn't make a whole lot of difference, the fact that this is an inequality. Really the only place it came into play was right here, where we had to switch the sign. Okay. And if you always forget to change the sign when you divide by a negative sign, it's actually the same thing if this is an equal sign. Right? If we had -2x equals -7, and we divide both sides by -2, you get x 7/2. You are, let me write that a little more clearly. When you divide by a -2, you are flipping this sign. But when you flip an equals sign, it's still just equals. Okay? So it's not like this is special. You always flip the sign. It's just with an equal sign, it looks the same. Okay? It's one of the things I love about math. It always makes sense. It always makes sense. There are always rules and they always hold. When you divide by negative, you always flip the sign. It just doesn't matter here. Okay, so we've done this one. Now we've got this one. You'll see that the original setups look pretty similar. Okay, we've got a number to an algebraic power here greater than a fraction, 1 over something. So what I would encourage you to do is to try and get as far as you can on this problem. Pause the video, use what you've got here, work it out on your own, see what you come up with. Okay. If you're still uncomfortable, maybe just try and do one step at a time. So do the first step and then see what I get. Then pause it again, do the next step, see what I get. Okay. The more of this you can do on your own, the better shape you'll be in when you work on the homework. Okay. So think about what you might do to start here. What would you do first? Well, step 1 is to get those bases to be the same. And it would be really nice if we could write this number, 1 over 243, as 3 to some power. So 1 over 243 equals 1 over 3 to the some power. I don't know what that is right now. So I'm going to take my calculator and just keep multiplying 3. 3 times 3 times 3 times 3 times 3. Ah, there it is. So it is 3, 9, 27, 81, 243. 243 is 3 to the 5th power. It's 5. Okay? So again, this is good, but we need to be able to write this as just 3 to some power. So to get it out of the bottom of this fraction, we take the exponent and make it negative. So this is 3 to the negative 5th power. Once we know this, we're going to write what we started with, but we're going to change 1 over 243 to this, 3 to the negative 5th power. So we've got 3 to the 4 minus 3x power is greater than 3 to the negative 5th power. All right, this is where these bases aren't really doing much for us anymore. Okay, we've got the same base. Our exponents are simplified. We get rid of those bases, and we write what's left. 4 minus 3x is greater than negative 5. And we want to get that x by itself. If you have trouble with this new exponential function stuff, but you're pretty good with things like this, and you haven't solved it yet, pause the video here, take it from here to the end. You're just moving stuff around until you get x by itself. Pause the video if you need to. I'm going to start by moving the 4. Negative 3x is greater than, this is negative 9. We're moving further into the negatives when we take a negative and subtract. And to get the x by itself, again, one of the most common mistakes I see from this point, you can get it right all the way to here and still get the wrong answer if you add 3 to both sides. This is negative 3 times x. You're multiplying x by something. So to get the x by itself, you've got to do the opposite of multiplication. Divide by negative 3. These cancel out. This is x. Negative 9 over negative 3. Negatives cancel out. 9 over 3 is 3. And this sign, I really hope you write it this way. It does flip around, again, because this is a negative number you're dividing by. Negative. Flip sign. Okay. Only because this is a negative number, you're flipping the sign. Same thing here. If the number in front of x was 5, and you divided both sides by 5, this sign would stay the same. It's only because we divided by a negative number on these that we flipped the greater than signs to less than signs. But that is what we end up with. X is less than 3. Okay. So, between what you saw in yesterday's video, I think it will be yesterday's video, the last video, and this one, you should have everything you need to get through the homework problems. You're going to have, at least as it is right now, you've got 4 problems. They're just solving equations, so that's like the last video. You've got 2, like this one, where you're given the y-intercept and one other point, you need to write the function. You'll follow the steps for this one. You've got 2 inequalities like these. And then there is a word problem at the end. And what I want to say about number 9 on the homework. So this is a test to see whether you're still listening and paying attention. On the last homework problem, number 9, you should be able to write it using this. Okay, you should be able to write it using this. It tells you how many clients someone had at the beginning. That number is the y-intercept. So that number will go here. And it tells you after so many years how many clients they have at that point. That's like this point here. Okay, so I'm probably going to treat that problem kind of like extra credit. If you get it, great. But what's important is that you submit that assignment on Canvas, and I'll give you an opportunity to upload a file for your work that you do. So if you show me that you work on these homework problems, even if you don't get them all the way correct, you'll still get credit for them. Okay, I think that's a pretty good deal. It's been that way all semester. As long as you show me that you're doing work, you'll get the credit for that homework. So give those problems a try for your next e-learning day. They'll be due by next Tuesday. That's the due date for the homework. I would recommend starting it before Tuesday though. And that is it for today. So thanks for sticking around. I appreciate it. Hopefully you've learned a lot about solving exponential equations and inequalities, and I will see you for the next section. Have a good day.